The batch processing framework is a KPAO project that can be used as a template to implement your own queues. Having a queue is very beneficial, specifically when it comes to parallel executions of robots or to asynchronously execute a batch of tasks and by providing transparency about the progress. The centerpiece of the framework is a database that must be Microsoft or MySQL database. And we can provide multiple queues in this database by providing different task configurations. In a configuration, you will associate a schedule to a queue, and the schedule will hold the process task robots that are responsible to execute these from the queue. Another piece that is important is a robot that is adding tasks to the queue. And the data sources can be anything. That can be a database, that can be a website, that can be a document, an Excel document, for example, or anything else. So this is taken by the add-task robot and persisted into a generic XML format, which is kept along with a task in the database and taken as an input for the process task robot to execute the task. That can be, for example, adding data into SAP on a desktop or adding data into any other desktop applications or modifying some websites, etc. and so on. So again, the data targets can be various systems where process needs to be completed. The main controller, the main schedule serves as a controller, and this controller will monitor the content of the queue to see whether or not there are new tasks included. And if there are new tasks included, it will activate the schedule, which in turn will start robots to process the tasks. You can tune the system by providing a different interval for the schedule to be started, and also by including one or more process task robots to orchestrate parallel executions. The configuration allows to apply different settings, for example, the maximum number of retries, the timeout, that means timeout that covers the length on which a task needs to be completed. So this can reflect an SLA, for example. So let's say your task needs to be completed within 60 minutes. So you would set a timeout of 60 minutes. And if this time is over, the main task robot can implement an alerting, for example, by email to get notifications of overdue tasks. There's also a couple of other values that can be set, for example, a delay. So that might be that you add a task into the queue, but it shouldn't immediately be started. It should wait, for example, for an hour and then start it after an hour. Okay, let's have a look at the Design Studio project. In the guide that comes along with the Qt processing framework, you will find an instruction how to set up this project. There is a generate database schema robot that helps you to set up and configure the database. And there is a generate example files robot that will create some Excel documents that we use for testing the setup and if everything is working correctly. So each of the robots contains a help section. So when you click on the click here first button, you will see documentation about what this robot is doing, what input parameters it expects, and what values you can set, etc. So all I have to do now is just switch to debug mode and start this robot. And it will create 20 example documents. So here we have the 20 example documents. And now, as next, I'm going to use the add task robot to import these documents into the queue. Before I do this, have a look at the config task robot. So this robot is intended to be used in Design Studio, and it's a utility to view how many queues you have created. Okay, so this is the configuration. Configuration is already provided for this 3 queues with the Kapao project. And then we have the first thing to do is add tasks to the queue. So this is an add task robot that basically iterates through the folder with example files and is creating a task for each of the purchase orders. So just running this also in debug mode. So here are the tasks created. The data, like I said, is persisted in XML. This is very easy to do. You can have a look at the examples robot. I simply converted a Kapao type to an XML structure and saved this in, along with the task entry in the database. This is a way so that you can use the same queue framework for any kind of data that you need to process with your robots. Let's have a look at the task queue in the database. Here are 20 tasks added. The status is new. And then we inspect the schedule. So here is the maintain process task schedule. It's not activated yet. So this, like I said, is the main controller schedule. It should be active all the time. And you decide the interval. It should be reasonable to fit within your timeout values so that you see immediately when there are new tasks in the queue, so that the maintain tasks process is activating the correlated schedules. Saving that and activate it. It's now started, and now we can also inspect and see that robots are started here. And when we look into the database, we see a couple of them are in progress, 2 of them are failed. And as we watch this, as we go along, we see the progress as it's as the robots are executing. So this might take now a few minutes. If a task is failed, it will do a retry, but it will wait for 3 minutes before the retry actually is started. So here there are these 3 are successful, these in progress, etc. and so on. That verifies basically that the setup that you've done at the database is working. So let's see a more advanced example. Let's have a look at there are 2 desktop projects included. So this is one taken from the supply chain management demo, using the Customer 360 applications. And I have also a task configuration for this one. So this is looking at the process here, the schedule task for Customer 360. So I take the same purchase orders for that second queue and simply run this again. So this will import now 20 more records into the task queue. So here we can see the 20 new tasks for the Customer 360 applications. And if we watch the robots as they are executing, we can see that Customer 360 robots will get started in a moment. So here we see Customer 360 robots get started. What will happen is that at this time I don't have desktops online. So the task will start with a robot, but the robot cannot access a desktop and it will fail. The status will remain new and it will retry this almost unlimited amount of time. So until then finally the timeout value hits, and maintain task robot can then react appropriately by sending out an email for notification of overdue tasks, etc. Basically it will try to access desktops until they become available. So let's see now what happens if I bring a desktop online. So here's my first one. Let's start this one. And I'm also starting a second one. And as you see, desktop becomes online, and the robot is adding data into the application. And here we have the second desktop, and also robots running now in parallel and adding tasks to the customer 360 applications. The queue mechanism will take care of that one and the same data will not be processed twice. So therefore the database schema contains stored procedures that are transaction safe. So once all data has been added, we can again look at the data in the queue and select set a filter here to only get the process task robots, and you can see all 20 tasks have been completed successfully. The batch processing framework contains also a report caplet and a robot for this one, and create reports robots. This is a simple way to get a statistic or about the current usage, but the more better way is actually to use the Insight dashboard that I've provided along with the batch processing framework project. So this dashboard here lists a summary of the current tasks. So this is currently in the queue. You see this is live data, so that is taken out of the database. You see how many new, how many failed, and how many in progress are at the moment. Here you will see in this summary how many tasks have been with which status: abandoned, error, and successful. And you see also in this diagram here how many tasks have been in the queue at which time. So then you can see also identify peaks in the queue. You can select robots as a filter, and you can select the time interval as a filter to narrow down the metrics data here in the view. The dashboard has a second page, which is a task list. So this again is broken down by for each queue. So here is the purchase orders example robot, and you see again the number, the sum of the various tasks in which status, and you can inspect the details by drilling down, and by clicking on each item you get the detailed information, including the XML data and the execution ID. So in case there is, for example, the status abandoned happens when a task is started in progress, but then for some reason never finished. So that could be that the robot failed due to an exception and crashed, so to say, so without updating the status of the task. So that will then taken by the maintain tasks robot, and the maintain task robot will set the status to abandoned. And then you probably want to see what was wrong with that robot, and you can take the execution ID and go to the management console, to the log view, to search for this execution ID and to get information about what happened, which kind of error happened for this robot execution. I hope you will find this very useful. It has been already used in various POCs and pilot projects and proven to be a very useful and robust solution to solving these kind of problems.